Lesson 2, compound interest. So compound interest is much better than simple interest because what happens is that when you earn money, your interest compounds on itself, so you start making interest on your interest. So say you started with $100 and then you earn 10% interest. So the first year, you're going to make 10% interest. Then what happens is it compounds and it's like it starts over. So it adds your interest and now it's going to compound on this. So then this year you'd make $11 and then it stops, compounds on itself, and now you'd have $121. Then it calculates interest on this. So what happens is it starts getting exponentially bigger the longer that you have it invested. And depending on your rate and how much your principal is, you can make a lot of money. The most important thing to remember about compound interest is that it's better to have it invested for a long time with a lower rate than to have it invested for a shorter time with a higher rate. Does that make sense? So really, the thing that makes a difference is how long it's in. High rates are good. You can usually invest less money for a longer time and make more money than investing a high amount of money for a short time. So that's why they tell you that you should start putting money away when you're young so that you can accumulate some compound interest on that money. Okay, so things that you need to know are compounding periods. So annually means it's compounded once a year. Semi-annually is 2 times a year. Quarterly means 4 times a year. Monthly obviously means every month, so 12 months. Weekly is once a week, so it's going to be 52. And daily is every day, so 365. So we are going to show how compound interest works. So if you invest $4,300 at a rate of 3.8%, compounded annually for 3 years, how do you get the compound interest formula? So if we think of just our interest, we calculate our interest by PRT. So we take our principal times our rate times our term. And since our rate is annually, this needs to be your annual rate and how many times per term. So if we put in 4,300, we're going to multiply it by 1 plus 0.38. I wrote the wrong formula down. So the principal multiplied by 1 times the rate times the term. So because we're just going to first just talk about 1 year, it's going to be 1.38. And by 38, I mean 0.38, because this is not a 38% rate. Alright, so if we calculate that, after 1 year, we would have made $4,463 and 40 cents. Okay, to look at this like a tree, we're going to take at 0 years. So at 0 years, we have $4,000. Then, to figure out our first year, we have to times it by 1.038. And when we times these two numbers together, we get 4,463.40. Then what happens now after 1 year is it's going to use that number to compound. So it's going to times it by 1.038. Together, they tell us how much we have going into our second year. So going to our second year, we're going to have $4,633.01. Now to go into our last year, we times it by 1.038 again, And so in our third year, we would have $4,809.06. So as you can see, 3 years, we have to times it by 1.038 to the power of 3. So what we're taking is we're taking our principal and we're times it by 1.038 to the power of 3. So our principal times 1 plus the rate to the power of the term. So this, though, is only taking into consideration, let me write that bigger. This is only taking into consideration that it's compounded annually. To show that it's compounded quarterly, if we were doing it 4 times a year, this would have to be multiplied by however times we compound it. So it would be 4 times the term. And our rate is only calculated, because this is calculated per year, to find it per however many compounding periods it is, you divide it by compounding periods. So this is the formula for compound interest. So we have a $23,000 investment in an account that earns 3.6% compounded semi-annually. The interest rate is fixed for 10 years. You want to use the money for a down payment on a house in 5 to 10 years. What's the future value after 5 years and also 10 years? So we don't know A. Our principal is $23,000. Our rate is 0.136. And our term is going to be, for the first one, 5 years. We'll do 5 first. So using our formula, we have A equals P times 1 plus the rate divided by how many compounding periods we have times the compounding periods times the term. So we have 23,000 times 1 plus 0.136 over, now it's semi-annually, so our N is 2. It compounds twice a year. So because this is an annual rate, we want to show it as a semi-annual rate. We divide by 2. And the number of times we get paid would be 2 times 5. Twice a year for 5 years. So this is going to simplify to 23,000 times 1.068 to the power of 10, and you should get $44,405.87. So that would be after 5 years. After 10 years is very similar. We're just going to do it with N equals 10. Our term is 10. Compounding rates doesn't change. So we're just going to change our 5 to a 10. So it's the same numbers, 23,000 times 1.068. This time it's going to be to the power of 20. You get paid 2 times a year for 10 years. You get paid 20 times. So it compounds on itself 20 times. And you're going to make $85,733.96. Alright, example 3. A mother is 50 and her daughter is 18. They're both investing $1,500 into an account with an annual interest rate of, I guess I didn't need to write that, of 9%, and it's compounded monthly. Determine the future value of their investments if they each hold on to this until they're 65. So obviously the daughter is going to have the better deal in this. She's got a lot longer to save. So for the mother, her P is 1,500, her rate is 0.09, the compounding is 12, and the term would be 50 or 65 minus 50, which is 15 years. So she's going to have her principal times by 1 plus the rate, 0.09. Right now it's per annum. We want it per month, so we divide it by 12, and you get paid 12 times 15 years. So we have 1,500 times 1.0075. When you type it into your calculator, that's what it simplifies to. And 12 times 15 is 180. So the mother will have $5,757.06. Now the daughter. The daughter's term is different. We have 65 minus 18 years. The daughter's got it in for 47 years. So the thing that we're going to change is the 15. This is going to be 47 years. 47 times 12 is 564. So all the numbers stay the same except for T, and the daughter is going to have $101,461.71. So it makes a huge deal putting that $1,500 in as an 18-year-old rather than waiting till you're a 50-year-old for it to compound. So that's why you want to invest money early if you can, so that in hopes in the future it will have made you some money. Alright, you're going to invest $3,000 for 5 years at a rate of 4.8%, so 0.048. You're going to invest it in each kind of term, so annually, semi-annually, monthly, weekly, and daily. So we've got room for this. So our term is still 5. I don't know how to put that. But our N is going to be 1 for annually, 2 for semi-annually, 3 for monthly, and by 3 I mean 12. I just started counting. For weekly, it's going to be 52, and for daily, it'll be 365. So, first we'll do our annually. So we have A is equal to 3,000 times 1 plus our rate, which is 0.048. Right now it's annually. We want it to be annually, so we don't really have to do anything. We can divide it by 1. To the power of, you get paid once a year for 5 years, so to the power of 5. So we have 3,000 times 1.048 to the power of 5, which is $792.52. Semi-annually, you start with $3,000. 1 plus, right now our rate is annually. We want it semi-annually, so you divide it by 2. And you're going to get paid twice a year for 5 years, which is 2 times 5, which is 10. So we have 3,000. 0.048 divided by 2 is 0.24, plus 1 is 1.024 to the power of 10. So you are going to get paid. Type this into your calculator as is. You should get, I forgot a 3 over here, $3,802.95. Monthly, we have 3,000 to start with. 1 plus 0.048, that's annually. To find monthly, we divide it by 12. We're getting paid 12 times for 5 years. 0.48 divided by 12 is 1.004 when you add the 1. So we have 1.004 to the power 12 times 5, which is 60, times this by 3,000, you get $3,811.92. Weekly. We start with $3,000. We have 1 plus. Right now, this is our annual rate. I put too many zeros. We want to make it weekly, so we divide by 52. And you get paid 52 times for 5 years. Now for this one, when you divide 0.048 by 52, you don't get a terminating decimal. So it's easier to keep this as a fraction until your final calculation. So we have 3,000 times 1 plus 0.048 over 52 to the power of 52 times 5, which is 260. So I would type the fraction first, add 1, raise it to the power of 260, then times 3,000, and you should get $3,813.69. So as you can see, the more compounding periods you have, the more money you make. So it's increasing by a little bit every time. And our last one, we start with $3,000. We have 1 plus our rate as an annual rate divided by, we want it daily, so 365. We were paid for 5 years, 365 times. And again, this isn't going to give you a good decimal. So we have 3,000 times 1 plus 0.048 divided by 365 to the power of 365 times 5 is 1,825. Type that all into your calculator. You should get 3,813.69. So what you should do now is you should pause the video if you haven't already and make sure you could type all of those numbers in to get the same numbers I did. Alright, the rule of 72 is very simple. All it means is it's a way to show you when your investment has doubled. So the only thing you have to do is you take 72 and you divide it by your interest rate. It doesn't matter how much you invest. It could be a small amount, it could be a big amount. It'll take 72 divided by your interest rate to double. So you invest $5,000 at 8%. When will it double? So 72 divided by 8. Leave the percent as a whole number. So 72 divided by 8 is 9. So it would take 9 years for your investment to double at 8%. So if it was 5,000, in 9 years it would be 10,000. If you started with $1, in 9 years it would be $2. It doesn't matter what number it is, that's how long it takes for your investment to double. Don't invest $1, it's not worth it.